We have a replica, not as good as the graph in the statement of the problem, and we're looking at the instant where these two protons, Q plus, they're right above each other in terms of the coordinate axis that we have. So if we use Coulomb's law for electric forces, we know that the electric force is K Q1 Q2 over R squared in magnitude, right? And because the charges are equal, we know that the charges are going to be repelled by this electric force, so the top one is going to be moving upward for upper proton. And recall that K is 1 over 4 pi epsilon naught. So we can write this as K. Since they're both protons, they have the same charge. R is the distance between them squared, would be R squared. So this is K Q squared over R squared. Now the magnetic force is given by QV crossed with B. So we need to find B first. And B for a charge moving is mu naught over 4 pi times QV crossed with R hat all divided by R squared, where R hat is a unit vector in the direction of the separation between the two charges. So this is going to be mu naught over 4 pi. QV is in the I hat direction. Right? It's moving in the positive X direction. Times R hat is in the J direction. It's by definition a unit vector, so that's 1 times R squared divided by R squared. So this gives us mu naught QV over 4 pi R squared. And when we cross an I by a J, we get a K hat. But if you forget, put your fingers along the V direction, curl them towards the R hat direction. Your thumb will be pointing in the direction of B to validate what was given before. And now the force on the upper charge is going to be Q times, we know it's a minus VI hat crossed with B, which is mu naught QV over 4 pi R squared K hat. And if we do this, if I take a minus I, so minus I would be pointing this way. Put my fingers in the direction of minus I, curl them in the direction of positive K. My thumb is going to be pointing in the positive J hat direction. And I would get a mu naught Q squared V squared over 4 pi R squared J hat. So that tells us where the Y FB is pointing upward. And now if we want, we can find the ratio between the two. Let's say FB in magnitude over FE. Just for the sake of comparison, this would be mu naught Q naught V naught over 4 pi R squared all over Q naught squared. And this might be a good place to notice that the Q naughts will cancel. So I have V squared over 4 pi R squared over K. I'm going to rewrite as 1 over 4 pi epsilon naught over R squared. So my R squares will cancel. My 4 pi's will cancel. And I have left a epsilon naught U naught times V naught V squared. So this tells us that the ratio of the magnetic force to the electric force is given by these constant times the velocity. And if we remember that we call U naught epsilon naught is the same as 1 over c squared. So this means that the magnetic force over the electric force is the same as v squared over c squared. This becomes important when we start talking about relativity in chapter 37.